1.5, describe angle pair relationships. So we have some new vocab here, and I'm going to be honest, if you know this vocabulary, we could stop after we get through it, because everything after that is just examples using this vocabulary. This section is one of those great sections in geometry where you learn why. I don't need to give a vocab quiz. But if you don't know your vocab words, you're not going to be able to do any of these work on a quiz, a test, or even on your homework. So the vocab is super important. I just don't need to spend the time giving you a matching section and telling you what does each word mean. So the first one is complementary angles. Now, just a quick side note. When I come around and say, wow, you look nice today. Ooh, I like your shoes. That's a nice hairdo. Those are compliments, and that little letter right there is an I, because it's talking about, I think you're doing this. Complimenting somebody is an I. Complementary angles are a different type of compliment, okay? Kind of like when you see complementary colors in art, that's the same type of word, okay? So these are two angles, only two angles, always two angles, never any more than two angles that add up to 90 degrees, okay? So you have one angle that might be 27. If you do that, you have another angle over here that needs to be 63, and together they add up to 90 degrees. Those are complementary angles. Supplementary angles, two angles that add up to 180. Once again, two angles, not three angles, not seven angles, but exactly two angles that add up to 180 degrees. Okay, so it doesn't matter where you see them at, it doesn't matter if they're touching or not, but it's two angles. So if I have a 150 here, I could have a 30 degrees over here, and together they add up to 180, and those are supplementary angles. Now, you need to know the difference between those two. You need to keep track of those two. So I often think of my alphabet. C becomes before S, 90 comes before 180. So the first one in the alphabet gets the smaller number 90, second one in the alphabet gets the S and the 180. Just one way I try to keep them straight. But you do need to keep them straight. Super easy problems we can do with these, but if you mess up your vocab, then we're in trouble. So try to keep them straight. Adjacent angles. This is all about location, okay? This word adjacent is all about location. If you think about your adjacent neighbor, they're the neighbor who shares your property line. They're right beside your house, okay? So these are two angles that share the same vertex. So I have an angle here. Now I have an angle here that shares the same vertex and the same side, and then it goes like this. These are adjacent angles because they share the same vertex and the same side, okay? So adjacent angles have to be there together, okay? Linear pair. The name says it all. Linear, that's a line, and a pair, which is exactly two. So it's two angles that create a line, okay? Two adjacent angles that form a line. But if you just think of I have a line and it's split into a pair, that's your linear pair. And then I have vertical angles. Okay, some of you know about these already, but when two lines cross, a vertical angle is straight across from another angle of that same size. So these are two angles formed by the same lines that are straight across from each other. Okay, I said if you know this vocab, you can do like the whole homework just from this vocab. So I've kind of drawn you pictures so you can visualize these, but one more thing here. We have math equations. On complementary angles, A plus B is going to equal 90 every time. On supplementary angles, A plus B, whatever your angles are, will add up to 180. Adjacent angles is the only thing that is a location only, okay? That means that I cannot set up any type of math equation from just knowing something's adjacent. A linear pair, look, it made a straight line. This means these two, because it's a 2 again, are going to add up to 180 again. And vertical angles, straight across from each other, some of you tried to answer this in 1.4's notes, but vertical angles are congruent, okay? So if this one over here is 75 degrees, this one over here is 75 degrees. So this is kind of a part equals part when you think about vertical angles. 4 of my 5 vocab words right there give me a math equation to set up just by knowing the vocab word. Okay, so that's going to be huge as we go through this. Now the rest of the notes, they're examples. That's what we're looking at from here on out, okay? So first one here, we're just going to talk about all these vocab words and what they mean and what we can find. So it says first in this diagram, name a pair of complementary angles, okay? So we're looking for complementary first, not nice ones that say pretty things, but things that add up to 90. Do I have two numbers in this picture that add up to 90? Sure, I see a 52 and a 38. 52 plus 38 equals 90. So let's name that 52-degree angle. Angle ABD up there, okay? Angle ABD. Quick question. I could also call this angle B, okay? If I said angle B, do you know where to look in the picture? Sure you do. There's only one place to look, so you are allowed to name that angle with one letter, okay? But when I look at this 38 degrees, it's this angle here. I can't just tell you angle D. There's a lot going on there, and you're not allowed to say just D because I won't know which one to look at. So on that one, make sure you call it angle BDC, or you can flip it and call it CDB, okay? But make sure you use 3 letters with this one. Angle B, I'm okay with because there's only one thing going on there, but angle D is not allowed. All right, second one. It wants me to name a pair of supplementary angles. So we're looking for supplementary angles, angles that add up to 180, okay? Looks like if I take 52 and 128, those two numbers add up to 180. So let's see, 52 and 128. Well, we already called that angle 52. That could be angle B again, and we're allowed to call it that. But that 128 is part of this confusing vertex thing, so I better name it angle BDE this time, so I make sure I go over to the E and catch that 128. All right, and my last question says a pair of adjacent angles, okay? Pair of adjacent angles. That's all about location. It needs to share the same vertex and the same side, okay? Well, I'll tell you what, those are the confusing angles. So I go to this D and I say, well, here's an angle it's creating, but it's also creating this one, okay? And they share this same line right here. That's what they share, and they share the same vertex D. You have to share a vertex and a side. So one of my angles can be angle BDC, and the other one can be angle BDE. Because they share a common vertex, they share a common side, so those are called adjacent angles. Okay? Notice on that, and you don't have to name them this way, but do you see how I have a BD and a BD, and then the letter behind it changed? So that's a good indicator that I have adjacent angles because they share that side, BD. Page 2. I'm going to tell you what, I think some of this is overkill on page 2. I'm going to just erase the work because I don't think I need it, okay? And on this question here, on A, it says angle 1 is complement of angle 2. Okay, as soon as I see the word complement, in my brain, I should have a number going off in my brain. What's that number? 90 degrees. So angle 1 is a complement of angle 2. So I have angle 1 plus angle 2 equals 90. That's what my brain should be telling me. So if I know that angle 1 angle 2 is 57 degrees, how can I find angle 1? Well, I can subtract, right? And I'm telling you what, you don't have to set up this sophisticated equation at all. When I subtract 57, it looks like angle 1 is 43 degrees, okay? So complement is 90. That's what we need to remember in our head. On the second one, for B, I have given angle 3 as a supplement of angle 4. I stopped because my brain just told me 180. Supplement 180. And it tells me angle 4 is 41. So if I think of angle 3 and angle 4 together make 180. If angle 4 is 41 degrees, how am I going to get angle 3? Well, I'm going to subtract 41, right? And angle 3 is going to be 139. Okay? Angle 3 is 139. So you can see right there that it quickly, if you can do the math, and you're good to go. Okay? While we're at it, let's just come right down here and do number 2 and 3 down here. Okay? Angle number 2 says angle 1 is a complement of angle 2. In my head, 90's going off. My first one is 73. I can do 90 minus 73. How big is angle 2? You got it, 17 degrees. okay? When I look at number 3, it says angle 3 is a supplement. So what's going off in my head? 180. So my first angle is 37 degrees, 180 minus 37, and I'm going to get 143 for the, whoa, it's going to look confusing when you look at that later. 143 for the measure of angle 3. Okay? We need lots of those on the next quiz, right? They're super easy, but you got to keep your vocab straight. You would hate to mix them and do them all exactly opposite. All right, so let's go ahead and say in this figure, we're back here on checkpoint number 1, name a pair of complementary angles. So it's always good as we start this to always remind ourselves what are complementary angles. Those need to add up to 90, right? So complementary angles. I look in my picture and I see 50 degrees and I see 40 degrees. So let's go ahead and name that 50-degree one. A lot going on there, a lot of confusion. I can't just call it E, so I need to call it angle D, E, F there, okay? But that angle 40 over here, everybody knows that that's just angle B. There's no confusion there. So if you want to name those D, E, F, and B, that's fine. You can always call it ABC. There's nothing wrong with calling it with all 3 letters, okay? Next one, supplementary angles. So I'm going for supplementary angles in my same picture. Okay, and I should be remembering that supplementary is 180. So let me erase these so I can see a little better. Supplementary, 2 numbers that add up to 180. I see a 140 and a 40. So the 140 is named angle FEG, and the 40 degrees is named angle B again, okay? I can call it ABC again. Either way is fine. All right, last one here is a pair of adjacent angles. And remember, that's location only, okay? So for my adjacent, I need to share the same vertex, and I need to share a side. Well, we kind of had that hint when we kept saying, here's where it's confusing, here's where it's confusing. That's where they're sharing things. Over here at B, nothing's being shared. Over here at E, we definitely have an angle here and an angle here, and they share this middle line. That's what we're looking for adjacent angles. So one of them on the maybe top, we could call it DEF, and on the bottom, we could call it GEF if we want to call it that way, okay? Once again, this one's a little bit different, but do you see how I have the EF in both? That's kind of a hint to me that we have some adjacent angles, okay? Let's move on, page 3. On page 3 here, I'm sure many of you have a basketball hoop hanging out in your yard with a few little algebraic expressions down by the ground. I mean, it seems natural here, you know. So we have a basketball pole here, and it forms a pair of supplementary angles with the ground. Oop, keyword, it's kind of speaking to me right there, supplementary. And we're supposed to find these angles. So as soon as I hear supplementary, I say, oh, they must equal 180. And it also makes sense, doesn't it, that I get a straight line, so that straight angle is 180. Straight angles, 2 angles that add up to 180, that makes sense. All right, so we plug in BCA. I get 3x plus 8. I plug in DCA, which is 4x minus 3. And together I know they equal 180. So let's go ahead and join our like terms on the side. 3x and 4x make 7x. Positive 8 and negative 3 make positive 5. Trying to solve for x, so I'm going to subtract 5. Need to solve for x, so I'm going to divide by 7. And looks like x is going to be about 25. Okay, so we're good, we're done. No, they didn't ask me for x. They asked me what's the measure of BCA, what's the measure of DCA. We need to plug it back in to get the actual measures. So BCA was 3x plus 8. We're going to plug in that 25 for x, so 3 times 25, and then add 8. 3 times 25 is 75, plus 8 makes 83. Let's try DCA. DCA is 4x minus 3. So if I do 4 times 25 and subtract 3, 4 times 25 is 100. Minus 3 makes 97. Now quick check, I have an 83-degree angle on this side, 97-degree angle on this side. Do those add up to 180? They do. Is my basketball hoop slightly slanted? Sure enough is, right? We usually think of those hoops being 90 degrees, but it's definitely not 90 degrees in this picture. All right. Down beneath it says, let's try the same problem, just a few different, and see how badly this one is slanted, right? So let's think about it. We still have these basketball hoop kind of slanted this way, B, C, A, and D was this way. This time it says, suppose the angle measures are 5x plus 1, label my picture, and 6x plus 3, find those angles this time. Once again, my setup's going to be similar because two angles together add up to 180. They're supplementary. 5x plus 1 plus 6x plus 3 equals 180. Join my like terms. 5x and 6x is 11x. Add 1 and 3 because they're also like terms for 4. Remember, we only do the opposite operation when we go across the equal sign. Now I'm going across the equal sign, so I'm going to do subtract 4. Get 176. I have 11 times x equals 176. To undo 11 times x, I divide by 11, and x equals 16. So let's plug it in just to check it. 5 times 16 plus 1. 5 times 16 is 80, plus 1 is 81. 6 times 16 is 96, plus 3 makes 99. What is 81 plus 99? Definitely 180. So those are definitely legitimate numbers for those two angles. And this basketball hoop slanted even more. All right, moving on. Let's talk about linear pairs and vertical angles, okay? So when we look at a picture, a linear pair, and remember, line, and it takes a pair, two of them, okay? So we're going to look for a linear pair. Now, I don't know why, but in the book here, they take the linear pair to the bottom and they put the vertical angles at the top. So let's look for our linear pairs first. And we need to basically find a line split into two angles, okay? That's what we're looking for. So can we find a line split into exactly two angles? All right, if we do this top line, it's split into two angles. So it looks like angle 2 and angle 1 together make a line. So I would say angle 2 and angle 1 are linear pairs, okay? By the way, this one says to find linear pairs, look for adjacent angles whose non-common sides are collinear, okay? That means the side they're not sharing, those two make a line, okay? So 1 and 2 work. What else works, though? And I'm going to erase my current line so you can see my next one. How about this line going this way? It's split into two angles, so I have angle 2 and angle 3. That's another and a different pair of linear pairs, okay? All right, let's go on to our vertical angles. Remember, vertical angles, and the best way to think about vertical angles is you need to have an X, okay? That's what it is. You need to have an X between two lines and their angles straight across from each other. If there's any extra lines involved, it's probably not going to be a linear or a vertical angle. So when I look here, it looks like I have an X formed right here, and the only one that has nothing involved in it is angle 1 and angle 3. So angle 1 and angle 3 are going to be my vertical angles. Look for angles formed by, I'm just going to put the little X there because that's the easiest thing to look for. Okay, so let's try this again here. Number 5, I'm going to start this time with the vertical angles since we just finished it. Okay, and remember, vertical angles have to be pairs, so formed by an X and straight across from each other. What do we see? Okay, I like 1 and 4 right there, 1 and 4. And I'm actually going to put congruent because they are congruent. Okay, what else do we see? All right, another X that makes 2 and 5, right? Angle 2, congruent to angle 5. And what's the last pair of them? Yep, angle 3 with angle 6. Okay, so we have 3 different pairs of vertical angles formed by those X's, okay? Now, remember, these 1 and 4 are congruent, 2 and 5 are congruent, but that doesn't mean that they are congruent with each other as far as 1 and 2 don't have to be, but 2 and 5 have to be, right? Okay, in the same picture, they want us to find the linear pairs. All right, linear pairs. So a pair of angles that create a line. What do we have for linear pairs? Somebody says like 3 and 5. Now be careful. Together, they don't make a full line. There's a big gap. So that doesn't work, okay? We can't do that. We have to have a full line with 2 angles because pair is just 2. Here's the deal. There are none in this picture. There's too much going on. We don't have a linear pair, a pair with a pair of 2 to make a full line. So we can't do that one, okay? All right. Let's grab this margin one while we're here. It says find the values of x and y. I see a big X with my angles. And it'd be really nice to go across from each other, but the problem is this one has an X and this one has a Y, and I really can't do an equation with both variables. Don't forget the rule from before. Here's my linear pair, right? You can work with these two together. And that tells me that those two will equal 180. So I can go 6x minus 11 plus 2x minus 9 should equal 180. So always look for different options with different problems or pictures depending on where your variable is and what would be the best way to solve. Joining like terms, I get 8x. Minus 11 and minus 9 together make minus 20. Solving for x, I'm going to add 20 to both sides. And now I'm going to divide by 8, and it looks like x is going to equal 25. Okay, so I found x, and remember, I'm just finding the values of x, so I'm halfway done, but I need to find y. Now it might be beneficial to go ahead and take my 25 and plug it back in. What's 6 times 25? That's like 6 quarters, right? $1.50 minus 11 would be like 139 degrees, right? What do we know about 139 degrees? Well, if this side's 139, its vertical angle over here should also be 139. So now I can say 139 equals 20y plus 19. Subtract 19. And of course we want to, whoa, sorry about that. Just trying to move it. All right, divide by 20, and it looks like y could equal 10. Okay? So you can use linear pairs if they're side by side and the numbers go together. You can use vertical angles if the numbers across from each other work well together. Wow, my math is terrible. Let's try this one more time. 120 divided by 20. How about 6? Don't ask me where the 10 came from. Okay, I think it's about time I put this away for the day and let my brain rest. All right. Into a story problem here. 2 angles form a linear pair. As soon as I see linear pair, I'm going to draw a line and change it into 2 different angles. That's the easiest way to draw a linear pair. It says the measure of one angle is 4 times the measure of the other. I don't know the other, so I'm going to call it x. And now this one is the measure is 4 times this. 4 times that is 4x. That picture organizes what I need. Because it's a linear pair, we know they're going to add up to 180. Okay? So I have an x plus 4x equals 180. X plus 4x is 5x. Divided by 5, and x is going to equal 36. I can find the angles by plugging in. X is going to be 36. And then when I do 4 times 36, I find the other angle is 144. When I add 36 and 144 together, I get 180, which is perfect because that's what I should get. All right, finally the last page. This was a long one. So the first one here, another word problem. 2 angles form a linear pair. I'm going to stop right there and draw it. There's my line. There's 2 angles. Measure of one angle is 3 times the measure of the other. My other should be x. I know nothing about it. The 3 times the other will become 3x. What do I know about my angles together? Well, they're a linear pair. They equal 180. They make a line. 3x plus x is 180. That gives me 4x equals 180. Divided by 4, x is going to equal 45. Now to find my angles, the x is 45. 3 times the 45 makes 135, and together those two angles would add up to 180, so we're good to go. All right, let's grab this one in the margin because you have one similar to this in your homework here. In the directions, you'll be told A and B are complementary angles. Remember, let that ring in your head, 90 degrees, complementary 90. All right, it gives you a measure for A, it gives you a measure for B, and it says find their measures. Remember, we're looking for numbers when we're looking for these measures. So what do we know about complementary angles? They add up to 90. So I'm going to go the measure of A plus the measure of B equals 90. And it's a plug and chug. In for A, I'm putting in 4x plus 31. In for B, I'm putting in negative 2x plus 44. And together they equal 90. Joining my x's together, 4x and negative 2x is 2x. 31 and 44 is 75. And they equal 90. Subtract 75, I get 15. Divide by 2, I get a decimal or a fraction, however you want to look at it. I'm going to leave it a fraction. Okay, the question didn't ask me for x, the question asked me for a and b. Okay, so let's go to measure of a. It was 4 times my x of 15 over 2 plus 31. Okay, I like this fraction because here, 2 cancels with 4, makes it 2. 2 times 15 is 30, plus 31 makes it 61. That math wasn't bad with the fraction there. For the measure of b, I'm going to do the same kind of thing. I have negative 2 times 15 over 2 plus 44. So again, this 2 and this 2 cancel, makes it negative 1, so I get negative 15 plus 44. A little different to get a negative to work with, but that's the way this one goes. So when we join those two together, we get 29 degrees. And if you think about it, 61 plus 29, does that equal 90? It does. So it makes sense that A and B are complementary. Okay, last little bit of notes here. And this, when it calls this a concept summary, it's basically saying, hey, I want to talk about some things we've looked at, or give you some warnings about things you shouldn't assume or might think you're going to assume, but we shouldn't, things like that. Okay, so it says interpreting a diagram. We see a diagram in our homework, in our book, on the board, and we want to say, what are some things we can always know? So when I see this picture here, and I look at it all combined, just know, all of those points have to be coplanar, because we see them on the same flat surface. That means, yeah, they're on the same plane. We look at points A, B, and C. We see a line joining them. Whoa. Sorry. If we see a line joining them, we can say definitely those have to be collinear. Okay, we can see them on the same line. You can trust that where you see them there is. You can trust that B is between A and C because you can see it on the line. All right, we see things like AC. This is line AC. With line BD, with line BE. They all come together and intersect at point B, okay? We can see that, we can trust that, all of that's happening, okay? We have angle DBE. This is angle DBE. We have angle EBC in there. If they share the same side and we can see it, we know those are adjacent angles, okay? It's something we can see in the picture. We can trust that they are adjacent. And we look at angle ABC, straight across. We can tell that's definitely got to be a straight angle, okay? We can trust our picture to know that. We can look and say, point E, is it between angle DBC somewhere? Definitely. So it's somewhere in the interior of that. All these location things we can trust, okay? Wow, I'm not having good luck here today. These are things we have to be careful with. We can't look up here and say, wait, can I look right there and say that's a right angle? I don't know. They didn't mark it. I'm not allowed to guess. That's a measure. I can't assume it. Can I look and say that over here, these two angles are split equally? Are they bisected? I don't know. They didn't tell me. I'm not allowed to assume that. What about down here? Can I think this side is equal to this side, that they're congruent? They kind of look that way. I'm not allowed to assume it, okay? So what this is warning us of is don't assume too much, okay? And what I really want you to think is this, what I've written down here. Unless it's marked, do not assume congruent or right angles, or really any measure, okay? Unless it's marked, do not assume a congruent or right angles or any measure, okay? They need to give us more information. They need to either mark it or tell us in the directions. Okay, that's it. That's what we have, okay? So for homework, you're going to look on page 38 to 40, and you're looking at 6 through 44 even, okay? Show me your work, especially when you're solving for an X and plugging it back in for your complementary and supplementary. Some of the supplementary and complementary ones you can probably do in your head. Don't show me your work if you don't have to, okay? Keep it reasonable. Ask me questions if you're not sure.